Indonesia. My name is Amalia Rohmah, the representative of Yogyakarta State University for Pemilihan Mahasiswa Berprestasi Nasional 2018. For this special event, I'd like to present my research entitled Cultivatech, Internet of Things-based contouring system and data acquisition of room temperature and humidity to increase the effectiveness of oyster mushroom cultivation. In the national development, the agricultural sector plays a strategic role. It contributes significantly to the achievement of the goals and objectives of Sustainable Development Goals programs, namely human welfare, focusing on the efforts to alleviate poverty and hunger. One of the farming subsectors currently developing and in great demand is the horticultural crops of oyster mushrooms. The fact that their nutritional content can cure various diseases causes the market demand to increase from 20% to 25% per year. In 2015, the demand for these mushrooms reached 17,500 tons per year. However, only 79% could be fulfilled due to the difficulty of creating a suitable environment in terms of room temperature and humidity for the mushroom growth. For example, in the mycelium phase, the mushrooms can grow well at a temperature of 22 degrees to 28 degrees Celsius and require a relative humidity of 70% to 80%. With an appropriate technology, the temperature and humidity can be set as needed. One alternative to lower the temperature and humidity is by watering, usually done manually, which makes the yield of the cultivation process become ineffective. The result in the yields, which are not optimum, and this becomes an obstacle for a broader market expansion. On the other hand, the development of the industrial world has entered the industrial era 4.0 and cyber-physical production process, where the production process runs on the internet as the main base, not only limited to communication, but also remote control. Cultivatech is equipped with hardware control, Android software, and a cloud server as a data storage sensor so that efficiency in the oyster mushroom cultivation increases. The Cultivatech system works by regulating the desired room temperature and humidity and controlling it through a web server available through the internet network. The result of sensor data readings processed by ESP8266 Wi-Fi module can be viewed and restored whenever and wherever. The main feature on the server is a unique code in the form of application program interface for writing and reading the user, who serves to send and receive data between devices. In addition, the data interface can be viewed on the Android software, where there is an option to activate the sensor manually, which means that the sensor works according to the temperature and humidity needed in the cultivation of mushroom. In monitoring data, Cultivatech has a variety of excellent features consisting of cyclometer and graph data record working well when displaying the sensor data according to the sensor readings. In addition, Cultivatech apps has a manual control feature to power the tested actuator hardware and works well when used. The effectiveness of Cultivatech is divided into several variables that facilitate its users, such as automations, time, and data recording in the high-tech cultivation era. The automatic variable is assessed based on the activation system of sprayer actuator that do not need human intervention. Time needed for watering the mushrooms using Cultivatech is 5 hours more effective when compared to the manual watering and 2 hours more effective than the watering by using other tools. Thus, Cultivatech is more efficient in carrying out the treatment of oyster mushrooms. It's expected that this tool can minimize the occurrence of crop failures caused by the temperature and humidity factor, since it controls and monitors the level of temperature and humidity automatically. In this way, the cultivation of oyster mushrooms becomes more effective so as to bring good impacts to their production. Cultivatech, technology from Yogyakarta State University for Indonesia.